Imagine climbing a mountain before sunrise. You reach the summit, raise your camera, and take what looks like a perfect photograph of the landscape. But when you zoom in, there is a dark mark at the center of the frame. At first, you think it is dust on the lens, so you clean the lens. The mark remains. You change the lens. The mark remains. You turn off every filter, reset the image, change the lighting, even take the photograph again from a different angle. Still, the mark stays fixed in the same place. At some point, the question changes. Maybe the mark was never in the camera. Maybe it was in the landscape. This episode begins with that kind of mark, not in a photograph, but in geometry, a trace that refuses to disappear. In the first file of this series, we asked whether reality is not simulated, but projected, not generated like a computer game, but selected as an observable slice from a deeper geometric structure. In the second file, we turned to quantum probability. We asked whether probability is not the universe's deepest language, but the grammar that appears only after projection. Now comes the third question. If reality is projected, what does projection leave behind? This episode is about residue. Not residue as dust, not residue as noise, but residue as a geometric trace, something left over after every legal transformation has been tried. In physics, many things that look real are only artifacts of description, a coordinate choice, a gauge choice, a mathematical filter. But some structures survive the change of description, and when something survives all allowed transformations, physics begins to take it seriously. To understand this trace, we need a wider language than ordinary general relativity. That language is Palatini gravity. In ordinary general relativity, space-time is described as if the map and the compass were locked together. The metric is the map's ruler. It tells us how distance and time are measured. The connection is the compass. It tells us how directions are compared as we move through space-time. In Einstein's usual formulation, these two are not independent. Once the ruler is fixed, the compass is fixed with it. That is elegant and extraordinarily successful. But Palatini gravity asks a deeper question. What if the ruler and the compass were never required to be the same system? What if distance and direction can be separated? The moment we allow that separation, space-time becomes more flexible. The ruler may still measure distance, but the compass can carry hidden structure. And one of those hidden structures is torsion. A simple image is this. Imagine walking across a surface that looks flat, but the compass you carry is slowly twisting as you move. The path may look ordinary, but your local frame is being rotated. Space-time is not only curved, it may also be twisted, like a towel being gently wrung from within. Now the problem becomes subtle. Some of this twisting may be real geometry, but some of it may only come from how we calibrated the compass. In Palatini and metric-affine geometry, there is a special kind of freedom called projective freedom. It is like recalibrating the compass without changing the visible path on the map. Under this transformation, certain trace-like pieces of the connection can shift. So a physicist must ask, is this trace real, or is it only a mark left by the way we chose to describe the geometry? If it can be transformed away, it is not a physical fingerprint. It is only a choice of language. But if it remains after the allowed transformations, then it becomes something deeper. This is where the key construction enters. The framework introduces a compensator field. Think of the compensator as the exact log of the filter settings. The trace is the image after the filter has been applied. The compensator is the record of how the filter was changed. Subtract the record from the image, and what remains is not the filter. It is the residue, a projectively invariant geometric trace, something that stays fixed when the compass is recalibrated. In the language of the photograph, it is the mark that remains after the lens, the filter, and the calibration have all been accounted for. The central claim of the paper is a local no-go classification. It asks a precise question. Can this residue be removed from the physical equations by any legitimate mathematical operation? Could we redefine the variables? Could we integrate by parts? Could we move it into a boundary term? Could we hide it inside another frame? Under the stated assumptions, four-dimensional geometry, local operations, linear curvature structure, and non-trivial dynamics, the answer is no. Unless the theory collapses into a trivial case, the residue cannot simply be erased. The fingerprint either remains in gravity or reappears somewhere else. A physicist might still try several escape routes. The first is the most direct. Declare the residue to be zero. But that is not removal. That is deleting the data. It is like smashing a computer's motherboard because the operating system has a bug. The bug disappears, but so does the computer. A second route is to integrate by parts. On paper, the residue may appear to move to the boundary, but the boundary is not an empty trash bin. It is more like a living carpet. You sweep the trace underneath, and the floor itself begins to move. The residue returns as a hidden coupling in the dynamics. A third route is to change the frame. The gravitational equation may look cleaner, but the residue can reappear in the matter sector. What vanished from geometry becomes an unexpected pull on matter, like pressing a wrinkle flat on a mattress only to make a spring rise somewhere else. Moved, not removed. And some escape routes damage something even more fundamental, the stability of light-speed gravitational waves. So the lesson is not that every trace is physical. The lesson is sharper. A trace that survives the legal removal tests is no longer just notation. It becomes structure. Now we can connect this to the projection view of PTQ. In the first file, projection defined the observable world. In the second file, probability became the grammar of that projected world. In this file, residue becomes the fingerprint left by projection. The PTQ perspective does not say that every anomaly is automatically explained. It says something more constrained. If the observable universe is a projected sector, then some geometric information from the deeper structure may survive the projection, not as a new particle, not as a mystical force, but as an invariant correction in the geometry itself. This is where the idea becomes cosmologically provocative, and also where we must be careful. Modern cosmology contains phenomena that remain unresolved. Galaxies rotate as if more gravitating mass were present than we can see. The standard explanation is dark matter, and that explanation remains the dominant framework. But the residue perspective asks a different kind of question. What if some part of the effect we attribute to unseen matter is actually a geometric residue of projection? Not a conclusion, not a replacement for dark matter, a question. Imagine searching for treasure using a map whose geometry is subtly distorted. You may think the treasure is missing, but perhaps the map itself is bending the route. In the PTQ perspective, the dark sector becomes a place to test whether projection leaves measurable geometric fingerprints. A serious theory does not replace one mystery with another. It turns mystery into constraints. So can the geometric trace left after projection be deleted? In a non-trivial physical world, the answer proposed here is no. Not if it is truly invariant. Not if removing it only hides it somewhere else. Not if the fingerprint survives every legal change of description. Then the residue is not an error. It is a message from geometry. And if it is real enough to survive the mathematics, the next question becomes unavoidable. Does it weigh anything? Can a projection residue bend galaxies? Can it leave a signature in the cosmic microwave background? Can the universe's hidden geometry be placed on a scale? That is the next file. From geometric residue to cosmic weight.